Hi, this is Yashika from Bright Mind Tutors. Today we will be going through electromagnetic spectrum for your IGCSEs and GCSEs. And usually I would say this chapter is approximately 2 to 4 marks, like it's for sure in your paper, and it comes every year. So let's start it without wasting time. Okay, like quick recap of this entire electromagnetic thing. I hope my screen is visible to you people. Yeah. Okay, so first of all, electromagnetic spectrum. So we have certain properties of the waves. Let's talk about them. All electromagnetic waves are transverse in nature. Now, what do you mean by the word transverse? So the word transverse means as the wave moves, like the vibration and the direction of the propagation are perpendicular to each other, like they are 90 degrees to each other. Like the wave is moving this direction and vibration is like this, like 90 degrees angle between them. Okay, I hope it works. So the second property is they all travel at the same speed in the vacuum. And what is that speed? Basically, that speed is 3 into 10 to the power 8 meter per second. Usually the speed is going to be given to you in your, paper. It's going to be that. So no problem. So, and actually one important part is this is actually the speed of light. The light travels at the same speed. Okay. So the next point is they transfer energy, not matter. As the waves are moving forward, there is a transfer of energy. Like energy is moving in the forward direction. Okay. So next is they can travel through the vacuum unlike sound. Like as you know, sound waves require medium for their propagation, whereas these EM radiations can literally travel through the vacuum and they can reach us. Like as the rays from the sun are actually reaching the Earth's surface, and the place between the sun and the Earth is complete vacuum, but they are reaching us. The last and the most important formula from this entire unit is they obey this V is equal to F times lambda. So V is equal to F times lambda. Like V is what? If I talk, V is your velocity. What is F? F is your frequency. And what is lambda? Lambda is our wavelength. So I would say this is the most important formula, and there is a kind of sure question. Like you're going to be getting this formula anyhow in your paper. So learn this formula, I would suggest. So if I talk about the units, what's going to be the units for velocity? Velocity is meter per second. Pretty important. Frequency is hertz, and wavelength is in meters. I hope this works. Okay. So the next part is actually the most important thing for your IGCSEs and your GCSEs. That is the order of the waves. So I'll start with the statement which says rich men in Vegas use X-ray goggles. So from the rich, what we have is we have radio waves. Fair enough. From the men, what we have microwave, and then for I have infrared. Yeah. And Vegas, V stands for my visible. U stand for my UV. Then this is my obviously X-ray, and goggle is my gamma rays. Okay. Please learn this. Like this is really important. Okay. Now, like the direction, if I talk about, as I move in this direction, basically my frequency is increasing. Okay, frequency increases. And you just need to remember one important thing, that is frequency and wavelength, basically your lambda or your wavelength, they are inversely proportional. Inversely proportional. Now, what do you mean by the term inversely proportional? Inversely proportional means as the one thing increases, the others can automatically decrease. So I can say as my frequency is increasing, my wavelength would automatically decrease, and other way around is also fine. Okay. So this is the chart, like the radio wave, they're going to have the longest wavelength and automatically they will have the shortest frequency. Correct? Then you have, as I'm, moving down, like longest, less long, less longer, less longer. And to the bottom, I have got my gamma rays, which going to have the shortest wavelength, but the other way around, it's going to be having the highest frequency. I hope this works. Okay. And now more like one important thing is like, just remember this quick thing. Sound is not like this kind of wave. Like sound, we can't apply these principles to the sound wave. Okay, let's move further. Next, you have the uses again. From this use, you can get a question, like if it's a long question, like let's it's a 6 marker, they're going to be asking you the use of one or two waves for sure, like at least one wave. So like I'll just read the uses which I feel are pretty easy for me to remember. You can learn any ways. There are certain uses written here. So let's talk about the radio waves first. I prefer learning broadcasting TV and the radio signals because the radio word obviously, yeah, and then I can use it for MR scanners in the hospitals. Okay, the microwave, as obvious, cooking, it's used in cooking and satellite communication. Okay, infrared, okay, remote part, because if you see, you have those remote control devices are there, where there's a small bulb in front of them. Basically, that is like the source of infrared. So it's used for TV remote controls and night vision goggles and thermal imaging cameras. Basically, IR is used to capture the images in the space as well. Okay, that respond to heat basically. The visible light, as obvious, human vision, photography, and optical fibers for the internet. Basically, it's the Wi-Fi technology. Okay, optical fibers for the internet. Then you have the UV. Okay, that's for sterilizing the water and the other equipments and treatment of certain skin conditions. Next, I have my X-rays, obviously broken bones, medical imaging, and then airport security scanners. That's quite obvious. And the gamma ones, that is again for sterilizing your medical equipments, radiotherapy that helps to kill the cancer, and yeah, that's it. I hope this works. The next is the harmful effects. Like there are certain waves which are pretty harmful to us. Like if I talk about the microwaves, like more exposure. Basically, at certain frequencies, these all waves are fine. Like, how what is the time of exposure? Like everything calculates. Like if it's a very teeny tiny time for exposure, they are absolutely fine. But if your body is exposed too much to them, then there are certain side effects which are written here. Like the microwaves, it can cause the internal heating of your body tissues. Okay. Infrared, your skin burns. UV, again, skin damage, skin cancer, skin cell damage, surface skin cells. And then you have the X-rays, like prolonged exposure to them, basically going to cause these things. And for the gamma, it's mutation of the cell. What do you mean by the mutation of the cells? Comment down the meaning of the word mutations in the comment section. Okay. The important thing is, as the frequency of your wave is increasing, it's going to be getting more and more dangerous for you. Why? Because, like more frequency means the wave is more energetic. If it's more energetic, it can actually travel, it can actually interact with our body parts. So it's getting more dangerous for us. Okay. You can see here as well. Like these are on the higher frequency side, means they are more energetic also. Like you can, remember this also. Frequency and energy are directly proportional. What do you mean by that? Like as the frequency of any wave increase, the energy automatically increases. Okay. Okay, then there are some protective measures which we can take against them. Like obviously you can wear your sunscreens, need aprons, or limiting time exposure. That's the quite obvious one. Okay, I hope the chat, like we have recapped this whole thing. And the good part is, if you know this all things, you have prepared for at least 3 to 4 marks for your IGCSEs and GCSEs. So now let's try to do the past paper questions quickly. You can pause the screen and you can start doing it. Otherwise, anyhow, I'm going to be doing it. So they say the sun emits infrared radiation and light. Light from the sun reaches the earth in 8 minutes. Okay, one thing, like one tricky part here is like from the light, they actually mean is the visible light. Okay, the word light doesn't mean like the whole spectrum of the sun. So that's like a wrong, I'll say the wrong choice of word, but yeah, this is how it is. So they are asking us which is correct and which is wrong. Okay, so the wavelength of infrared radiations. Obviously, you remember that thingy, what was that statement? If you guys can recall, rich men in Vegas use X-ray goggles. In Vegas, like infrared's gonna have the longer wavelengths, correct? Okay, so longer wavelength A and B, this and this, so anyhow rules out. Okay, And obviously now, the trickier part is like they're asking us the time taken for that wave to reach the earth. So now if you know, like all the EM waves actually travel with the same speed. The distance is same, the speed is same, therefore the time is going to be also be same. That is 8 minutes only. So it's my option A, longer than the wavelength of the light, and it takes just 8 minutes. That was actually a tricky question. The next you guys gonna do, and I need this answer in the comment. Comment the answer. Very simple. Okay. Okay. The next part you have is, that's pretty good. Which of the following is not the EM wave? Gamma. Okay, this is the symbol of gamma. This is how you write gamma. Okay. So gamma is infrared, is radio, TV, micro. They all are sound. Sound is not the EM wave. Correct? So sound. What is the nature of the wave you named in the party? What is sound? Sound is a particle nature. Particle means it requires medium for the propagation, like solid, liquid, or gas. There's need to be something, then only the sound would travel. So I would say it's a particle nature. Particle nature, or you can write compressions, rarefactions, longitudinal, like that. Okay. Okay, the remaining names in the list are all regions of the EM spectra, but one of them is missing. Name that missing region. Think. Which is missing? 5, 4, 3, 2, 1. UV is missing. Okay, fine. Now the last part, the most important question. See, it's like a 3 marker. And if you check, like this was a whole 6 marker and it actually covered everything that we have gone through. So just by this 10-minute lecture, you are actually ready for 4 to 5 marks. Okay, it says a television station emits a wave with the frequency this. Electromagnetic wave travel at a speed of this. What is the wavelength? What is the formula? V is equal to F times lambda. What is the velocity? 3 into 10 to the power 8. What is the frequency? 2.5 into 10 to the power 8 is equal to your lambda. And this get cancelled. So what's going to be your answer? Comment down the answer. And what's going to be the unit as well? Like that's that much meters. Okay. That's it. So let's do a quick rapid fire round. Like this is like the whole revision of the entire session. Fine. So all the EM waves travel at a different speed? No. Basically, they all travel at the same speed in the vacuum, 3 into 10 to the power 8 meter per second. Okay. Gamma has the longest wavelength? No. Radio waves gonna have the longest wavelength and gamma has the longest frequency. UV is used in X-ray scans? No. X-ray is used in the X-ray scans. Sound is a EM wave? No, it's a particle wave. It's a mechanical wave. Okay, it needs a medium for the propagation. Measuring frequency without knowing the frequency order, without knowing the visible spectra order. Basically, what does that mean? Red has your lowest frequency and the violet's going to have your highest within this region, basically. Okay, so like, the visible region is what? Vibgyor. This is your visible region. The word is Vibgyor. Violet, indigo, blue, green, yellow, orange, red. And as I move in this direction, the wavelength increases. Okay, the wavelength increases. So the red's going to have the highest wavelength and the lowest frequency, and the violet's going to have the highest frequency and the lowest wavelength. Microwaves are dangerous because they burn skin. No, the UV does. The UV burns the skin. What the micro do? They cause the internal heating of the tissues. Okay, students, that's all for this EM wave chapter. Hope you liked it. If you liked it, you can comment down the next topic you want our team to present. Okay, bye-bye. Happy learning.